All right, welcome to Doozer shop. I'm at the Bridgeport milling machine. I like to bring you guys setups of stuff that I'm working on. So this is the casting from the Covel grinder. And I'm contemplating, I think I'm going to do it. I'm going to put in an oil port. So that's the lead screw. No, that's the lead screw, and that's the crank, the hand crank idler shaft. And there's a gear inside there, does some reduction. But anyhow, what I want to do is in here there are two angular thrust bearings, and in here are two bronze bushings, oilite bushings. I want to drill an oil port to lubricate. I think I can do both of them, and it's kind of hard to see. I've got this clamp on it, but within, I think it's like 7/32 of the edge, I can drill a hole and put in a flip-top oiler or a ball oiler. So what basically I'm going to do is I'm going to use like a real small drill bit, like an 1/8 inch drill bit. I'm going to drill. The bearings are in here. There's two bearings face to face, and I'm going to drill and hopefully hit this passage right between the bearings where they're kissing face to face, because they're angular contact bearings. They run in pairs. And I'm going to continue to drill. I mean, the bearings are out of it, obviously. Continue to drill, and hopefully the oil will leak around the chamfers of the bearing races and lubricate the bearings a little bit in the process. And then drill through this cast iron again and break into this bore where the bushings are, the bronze bushings. So oiling that will oil the angular bearings, and then this passage is really what I'm concerned about, because it's bushings. The bearings can be greased forever. But I don't see a good way to get here from the top of the grinder. So this is the top of the machine, you know, and well, that's what I'm doing. I'm trying to drill an oil passage with a really long, skinny drill. So the setup is this. I need to establish some references. So the face that's sitting on the table is a machine face, so that's good. This is machined, that's good. This is machined, that's good. But I need something to align my drill bit, because I want to hit dead center of that bore and break into there, hopefully dead center. So what I got here is this. That bore is 3/4. I found a piece of 3/4 bar stock. That bore is 7/8. And I found, well, I didn't find, I made, it just happens to have threads on it because it was just a piece I had. This is a plug that's 7/8 on that side, and it's a snug fit in that bushing. I think it's like a thou over, and then it's 3/4 on top. So that's 3/4, that's 3/4. So now that I got the same shafts, plugs, and a dummy plug and a shaft in my holes, because I want to establish an alignment side to side, but you know, in plane with the center lines of those holes or the edges or whatever. So then I got my just a parallel. Probably made that in machining class years and years and years ago. As a straight edge, and I'm just using it as a straight edge, and I'm clocking, you know, between this 3/4 shaft and that 3/4 plug. And I've knocked around the casting on the table, tapping it ever so gently, and then I got the same number there is there. It's 0 straight across, or 15, or you know, whatever. The number doesn't matter. So what I'm going to do is, because this is cast, I'm going to take an end mill and mill a flat there, and hopefully equidistantly I'll mill a flat on the backside as well. And Then I can split the difference or know my measurement of half that, and I can get my drill located on center. And I can't do it face down. I got to put this on an angle plate. Or if I have flats on the side of that as cast boss and I have machine flats, you know, I can, I set it up next to it on the Kurt vise, right? I can clamp that, those flats in the jaws of the vise and stand this guy up in the vise. I just got the vise thrown over here on the Gorton for a minute, just because I needed the table of the Bridgeport. So anyways, that's my plan, I think. I also thought of clamping a little differently and milling a flat on the bottom here, because it's on the bottom, you'll never see it, just a register flat. Then I have side, side, and bottom, and this bottom is going to be 90 degrees obviously to those. So that's my thought. So when you have a casting and some machine surfaces and you're trying to pick up another perpendicular center line, you got to create some more reference surfaces, and here I'm creating two surfaces on either side of that boss protrusion relative to the center lines of both of those bores. And like I said, obviously you can't do it on one because you still have a rotational element, but when you have two, you lock that in and you establish straightness between the axes of both of those. Simple setup with just milling table clamps and 1, 2, 3 blocks. It just kind of worked out. But anyhow, that's what I wanted to show you. It seems maybe complicated, but it's pretty simple. But there's a lot of thought that goes behind this to figure out what do I need to get my alignments. And that's the fun part about machining is clamping things down and indicating things and trying to figure out your geometry, how you're going to align things to the axis of travel of the table. So, I don't know. I kind of nerd out on stuff like that, and I enjoy it. But anyways, let me leave this set up and think about if this is going to be the right way. But anyways, even if I tear it down and do something different, I wanted to show you guys the method, the thoughts behind my my setup here of this casting to add an oil hole. All this to add an oil hole. You know I went through depths to add oil holes on the apron of my Colchester 17. But anyways, this for me, this kind of stuff is fun, improving the machine, adding a point where I can lubricate this. Even if I didn't, it'd probably never wear out in my lifetime. But I think this is fun. All right, hope you found that interesting. Until next time, this is Doozer Shop.